All right, Unit 1. Time to learn some calculus. Okay? Now, Unit 1 actually isn't something that goes with us in terms of like, oh, we will be doing more of this stuff. But the theory stays with us. Okay? The understanding of what is a limit is used in calculus for the rest of the year, but on a more theoretical side of things. Okay? So at the end of this unit 1, we just need to understand the theory of the limit. If we end up not knowing how to do like all these problems on our homework for lesson 1, 2, 3, it's actually not going to come back and bite you. Once we get into unit 2, like that's the stuff that like, you need to know moving forward. Okay? Like you can't mess up. And so if you have an off unit, it's actually going to be unit 1 and 5. So know that. It's good. It's good to know. So it's very important to understand like the theory of visual limits, because that is totally used when we talk about what calculus is. Calculus, what we're going to be learning is the math of change. We're going to be talking about how things change all year. Okay? How quickly are things changing? How is the change changing? Cool. But another thing we can say calculus is the math of infinity or the math of infinitesimals. I don't know if that's how you spell infinitesimals. I don't even know if that's a word. But what do you think an infinitesimal is?
Infinitesimals.
Very small, yeah. Like the idea of like decimals. Very small things. Infinitely small. Okay? That's actually something important in understanding limits. The concept of being infinitely close to something, yeah, very, very small distance away, infinitely small distance away. What we're going to learn is two very like easy problems to kind of draw and to kind of see and understand. In the first semester, we are going to find a tangent line on a curve. We will find that like the meaning behind this tangent line, what information that comes from this is actually like really cool. It can be applied to a lot of different things. It's not really important right now, but like we'll be talking in the first semester about derivatives, what that means. Once you get into unit 2, that's when we get into what is a derivative. That's when the class like really starts. And then in the second semester, we will find the area of like an irregular shape. So the area under interval. Second semester, we're going to be doing intervals. What that means doesn't. Okay. We'll find that these two things are actually very related. We'll find that calculate the story. Learn something, learn something else, we'll apply it to the real world, we'll find it's really interesting, and we'll have a great experience in the class. But before we get there, we got to know about limits. Okay? Limits is building block. Building blocks. Building blocks, limits. Building blocks of calculus. Okay? We have to know the theory behind limits. To help us know the theory behind a limit, we're going to do some problems. We're going to set up certain types of problems to make sure, like oh, okay, if I know how to do this, I kind of know the theory behind it. Okay? And to help you understand limits, we are not going to talk about finding a limit for a while. Okay? I got just some like piecewise functions. You guys remember piecewise functions from last year? From my previous math class? You hate them. Don't worry, guess what? Guess what? You don't have to graph anything ever. Cool? Actually, once we learn Unit 3, you'll find that graphing becomes actually very easy. Once you know calculus, you can actually graph it. But until then, don't worry about it. Don't worry about graphing. Okay? We're just going to have to answer some questions. Like, hey, here's a function. What's f of 1? What's f of 2? What's f of 2? We'll start with those easy. Cool? Well, understanding that a function split into pieces. It's important to know, like, oh, okay, when x's are less than 2, I use this piece to determine my y. Understand if I ask you what is f of 1? This is an x value. I'm asking you to find what is an output or a y value. Understand that graphically, our x's or inputs into functions are on the x-axis. It's what we like use. We take those x's, we plug it into a function, and we output y's. Y's are like our function values. Okay? And I don't want to use actually, I will use that for x. If x is equal to 1, that's definitely less than 2. I will use x plus 3, plug in 1 into x plus 3, I get 4. Congrats, I just got my first function value. With the input of 1, I get an output of 4. Cool, then we'll pull it for you. Now for the next two, if x is 2, I realize x equals 2, it is greater than or equal to 2, which means I'm going to use this piece. Don't plug into that guy, because we're supposed to plug into this guy. Cool. Plug into that, I get negative 4 plus 5, that's 1, okay? At 2, I get 1. At 3, okay, that also is bigger than or equal to 2. So, I will plug it into this. I get negative 6 plus 5. Negative 6 plus 5 gives me my output, my y value, negative 1. At 3, I have y value, negative 1. Okay. But then we go to these. And I ask you, what if you plugged in 1.9999999? What if you plug that in? Where would you plug that into? And what y value would you be really, really close to getting if you plug that in? Talk to your neighbors. What do you think?
That's greater than
Okay. Ready? I know that this number is less than 2. Okay, that number is less than 2. Which means I need to plug it into x plus 2. Now I'm going to use my calculator to display kind of what you might have expected. Okay, ready? On my calculator, I will plug in 1.9999. And then I'll add 3 to it. Okay, so I plug it into the x plus 3 piece. We have 1.999. And I can see I get 4.99. Now immediately you look at that and you're like, oh, that y value is close to 5, right? Okay, cool. Now watch this with your calculator. Eventually, if you plug in more 9s, your calculator just gives up. And they're like, dude, that's just 2. Okay? You're literally just giving me so many 9s, I have to round. And if I have all these 9s and add 3 to it, I'm just going to tell you it's 5. And you know it's not 5. This is where the calculator is a little bit deceiving. You know that if you take 1 followed by 49, add it to 3, you're going to get 4.49, right? That makes sense? So you're not really at 5. Your calculator is deceiving you. But what your calculator is telling you is like, dude, you're at 5. Like, that's it. You are getting infinitely close to 5. So you say, I'm getting close to 5. Okay, what about this? If you plug in 2.0000000, an infinite amount of zeros. What's that going to be?
Is there a 1 at the end?
Yeah, sure. That way it's not 2. It's not 2, but it's just a little bit bigger. Cool. So this number is bigger than or equal to 2. You know, it's not equal to it, it is bigger than. All right. Well, that means I'm going to plug it into the bottom piece. If I plug it into the bottom piece, you know, it's going to be -2 times that number that's essentially 2, which is -4, and I'm going to add 5 to it, and then get a number that's very, very close to 1. You know, maybe you can do the math and think it's like, oh, it's probably like 1.0001 rather than like 0.99999. Either way, I don't care. That number is very, very close to 1. And it's like from this where like you can kind of see where the graph goes. You know? The red piece is used up until 2. Even 1.999, it's used. But we get infinitely close to, but we never get really to this value of 5, which is why we use this open circle to say we are approaching 5, infinitely close to 5. 4 point infinite amount of 9. And then we kind of go off to the left here. And then for the other guy, not only am I approaching this value of 1, but like I have the value of 1 because we are plugging in 2 into this piece, and then we kind of go off from there. And there you go, you just create a graph and okay. Okay. You can get the answers without looking at the graph. I'm challenging you to do these 5 questions, and if you think you have it, why don't you like check with your neighbors? If you and your neighbors disagree, maybe check with me. If you got it, and you're like, I got this, please help the people around you. This is why we're in these tables, so that you have a lot of people around you to help you. To help you. They have batteries?
Yes, all of those do. This one came with, or wait, no, not this one. That one came with batteries, but when I opened it up, they had like corroded. So that one does not have batteries.
Did you take them out? Take them out, throw them away.
Yeah, I didn't put them in there.
Oh.
So that one doesn't have batteries.
What's this?
Oh, that's a RFID chip. So like nobody can steal it off this mess. I don't think this one.
These are chargeable or these batteries?
Those are chargeable. Yeah, and then this one doesn't have batteries. And yeah. So this is the only one that has batteries.
Thanks, man. You're good, Rob. complicated thing. Listen, guys, this is actually important. In this class, you will not be successful if you try to memorize how to do problems. Many of your previous classes, you can get by being like, oh, if I see this, I do this. But in this class, you want to be successful, you got to understand why you do what you do. You got to be able to do it too. You got to know why. If you're just waiting for how do you get the answer, oof, it's going to be a long year for you. This class really builds upon itself. Definitely starting in unit 2. You can't just like figure it out. You gotta understand. Alright? So, 0. That's lesson 1. I'm using this stuff. I plug in 0. I get 3. 1. That's equal to 1. That's this guy. That's that guy. That's 6. 2. Okay, well that's bigger than 1. So I'm using this. Then I use that guy. And I get 6. Okay, those are the same, correct? Let's think about it. Next to 0.9999. Well, that is less than 1, which means I'm using the top. I can think about plugging in 0.99999, like my calculator kind of showed me. Yo, that's pretty much just 1. So you plug in 1, you get negative 1 plus 3, you get 2. You get it from the top guy. 1.0001. Oh, well that number is bigger than 1. So 1 is bigger than 1. I'm using the bottom guy. If you plug in that into the bottom guy, you get a y value approaching, getting infinitely close to it. Just 5. 1 plus 4. Cool? Cool. Easy. All right, good.
So we don't even know how to grab these?
Nope. Now, how do we grab this? All right, well, let's see.
Like with the line?
I'm going to have a point at 6. Great. I have a point at 6. That's my green point. I will approach that into my red line, and I'll get to 2. It's negative x plus 3, so I'm going like this way. And then the blue line is positive x plus 4, so it's going up, and it's approaching 5. So, why do I use open circles? Because the red line is going to approach 2 as I get closer to 1. The blue line is going to approach 5 as I get closer to 1. Cool? Right? The open circles are like, hey, we're getting really, really close to this y value 2 as I get really, really close to 1. But a little bit less than 1. If I'm a little bit greater than 1, I'm getting really, really close to 5. All right, let's keep going. Times. Do this here. Everywhere else. This is interesting. Tell your neighbors, what do you see here? What's going on? Okay, good. That's a good thing to do. Not equal to negative. No, it's good enough. That's fine. And if I don't get the graph, I'm going to find the answer right. This one was so really close to the top. What if my calculation Well, no, that's the word, yeah. It's not second. So.
Let's do maximum size. So, no matter what, we're not gonna need to know how to graph, right?
Don't need to know how to.
Can you grab this one though?
Stop it.
Can you
It's
grab
gonna
it
be
though?
okay.
Confuse me.
Guess what? This doesn't equal -2. This doesn't equal -2. That equals -2. This does not equal -2. This does not equal -2. Let me change the color. This equals -2, okay? So, whenever I got something not equal to -2, I got to square it. Cool? Alright, -3 squared, +9. 4 squared, +16. -2, 1. -2 point, infinite amount of zeros followed by a 1. It's not -2. So, I am plugging in that number into x squared. If I took -2.15 million zeros followed by 1, I plug that into my calculator in parentheses and then I square it. My calculator is just gonna be like, yo, I give up. Because like, I'm just gonna round, because you're essentially plugging in -2 and you're squaring -2, and I'm just gonna tell you it's 4. I'm not gonna tell you it's 4.000000001 or anything like that. If I plug in -1.9999999 and I square that number, I'm gonna get like 3.99999. It's essentially 4. Well, now here's what we actually see. At every other value except for -2, I'm using x squared. You should know Stan's law. And it just looks like a U, right?
Yeah.
James, you know what looks like a U? Evans. Sorry.
Yes.
Evans. You know what looks like a U.
I don't know. I'll get the question right when you give me.
Evans.
Wow.
It looks like a U, right?
Yeah.
Alright. Well, at -2, I'm told that I have a point at 1, right? Yeah. -2, 1. So Evans, what should I put here?
Open.
Yeah. I think I already changed it. Now, do you have to know how to graph that? No. Okay. Alright. Okay, let's go to the next one. Hold on, check it. Evans, good one. Did you need to know how to graph to get those answers?
No.
Alright. Now, it's not a piecewise. The last question I probably wouldn't even call piecewise, I'd call it like point wise. Because it's like using using x squared for everything except for point. But like, what's going on here? X squared minus 4, x minus 2. Well, I guess I could plug in 1 and 1.5 and 2 and 2.5 and 1.999 and 2.0001, and I'll just start plugging those in. Okay, let's plug in 1. Cool. 1 squared minus 4 is 1 minus 4, that's -3. 1 minus 2 is -1. I get -3 over -1. I get +3. Oh, I don't want to plug in 1.5. All right, now I'm going to skip it. Skip it. I'm lazy. It's just skip it. Plug in 2. Plug in 2, I get 0 over 0. You haven't seen this yet. You saw it last year. Is that 1? Is that 0?
0.
It's neither. Can't be done. Now this is like a crazy thing in FS. 0 divided by 0 actually could be anything. It's called undefined. We don't know. It doesn't exist. You are not allowed to divide by 0 ever. Okay? Even if it's 0 divided by 0. Got that? So stay with me with that. 0 divided by 0 is undefined. But man, I want to plug in 1.5 and 2.5. Because like I gotta plug in 1.999 and 2.001, but like if I plug in this, it's like plugging in this, and I'm gonna get 0 over 0. So it looks like these answers are undefined, too. Well, it turns out. Sorry, psych. So let's make this look a little bit different, so that maybe we can plug in 1.5 and 2.5 and 1.999 and 2.0001. And it's easier to do. You guys ever factored before? You factored? Steve, you factored? Yeah? We will factor a whole bunch of these. And when we factor, we realize. Now, pump the brakes, guys. Pump the brakes. Don't cross off the x minus 2's. Don't do it. Because then if you cross off the x minus 2's, you're going to tell me j of x is x plus 2. And you're going to plug in 2 into x plus 2, and then you're going to tell me that's 4. No. I'm not allowed to plug in 2 into this because I get 0 over 0. Got that? So, don't cancel. Don't cancel. But what it does show me is like, well, let's say we plug in 1.5. I get 1.5 plus 2 times 1.5 minus 2 over 1.5 minus 2. This number and this number, they will essentially cancel each other out. And we get a nice easy 3.5. That's not that bad. I don't have to worry about 1.5 squared and dividing it by 0.5. Let's look at 2.5. All right, well, if I plug in 2.5 into 2.5 plus 2, 2.5 minus 2, 2.5 minus 2, I realize it's like, oh, that 0.5 divided by 0.5, yeah, that will cancel, and I get 4.5. All right, that's easy.
So why would it not work for the other?
Well, let's think about plugging in this number and this number, and how it differs from plugging in 2. 1.9 repeated plus 2, 1.9 repeated minus 2 over 1.9 repeated minus 2. What's different about this than when I plug in 2?
It's 3.9.
No. Right? Think about it. Clemens, what's different about this than if I plug in 2? This isn't 0. It's getting close to 0, right? Infinitely close to 0. But is it 0? No. You're not allowed to divide by 0 ever. This isn't 0. It's really, really close to 0. So it's like you have 0, 0, but it's not. You can now cancel this, and that's okay. And you can say 2 plus essentially 2 is 4. Again, why was I able to do that? Because the bottom isn't 0. It's very, very close to 0. This is still undefined, but this is approaching 4. This number, same deal. It's not 0 in the bottom. It's not 0 in the bottom, it's close to 0. You can cancel that. And you can get 4. What we have is a situation of a graph created that has a hole, but does not have a point. J of x actually does look just like x plus 2. It's very simple. It just looks like this. This looks like y equals x plus 2, with one exception. J of x, x squared minus 4 over x plus 2, does not have a point at 2. At 2, it has an open circle, and that open circle's location. Cool. If you got it picked up, what I'm putting down, you'll be able to tackle all these limit questions. Last one. And then we actually switch to, hey, what's this limit? This guy. Plug in -2 into m. What do you get? Plug in -0.5 into m. What do you get? Plug in 0. What do you get? Plug in 0.5, plug in 2. Go. That's a -0.5, that's a positive 0.5.
Yes, I'm saying that. And then x is just
Wait, no.
You got it? I don't think
Divided by
so it's that's like greater
Yeah? Believe so? Yeah?
when you're graphing cosine, it's gonna cross out negative points you need for like
So, keep crossing. Just use that.
yeah,
Except for.
yeah.
We plugged into the only say it's 4 because this is undefined. So make sure you have that. It's undefined.
When you get a question, like the one before, should you always say the original equation? Like we would have missed that 2 was undefined if
Yes. Or when you factor, don't cross anything out.
doesn't matter what.
Don't cross it. All right. So what's cool about this function is that it's a naturally jumping function. We call this the jump function. Because of the absolute value, we'll get something divided by itself, but it's either positive or negative 1. So this will be a negative 1. This will be down, 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 down. There. Okay. This will be a negative 1. This is 0 over 0. 0 over 0 we talked about is undefined. This will be a positive one, this will be a positive one because everything's positive, okay? If we went just to the left of 0, again, we're not going to get 0 over 0. It's close to 0 over 0, but it's not. It's a number that's positive divided by the same number that's negative. This is also -1. Very good. If you did this, again, it's not divided by 0 anymore. You can figure out what it is. It's something that's positive divided by the same thing. They're very, very small. That's positive, and that's positive. This is how we create this jump function. You need to know how to graph that? Maybe it helps.
Is this something, I don't remember much, like what a hole is,
This is a jump.
Right, but like.
The last one was a hole. This is a hole. We did a lot of holes last year.
Yeah.
Okay? Now, your teachers might have told you to like cancel stuff, maybe a little bit too early. Just pretend like we're rewriting. Alright, good, good. So then we start over. Alright. Now, a limit. A limit is a y value that a function approaches as the input x value approaches some value. Okay? That seems like crazy, but I'll tell you, it's not. It's not. It's just what we were doing. It just looks different. Now here's a limit notation. LIM, x approaches a number of some stuff. It could be a function, it could be the equation of the function. It could be like x squared, or it could be f of x. So like, you can have anything in there, you can have a, what's the limit of f of x, or you can have, hey, what's x squared is the limit, you know? That equals another one. This number is an x value, this number is a y value. Now, some important things about limits. We can look on one side or another. X approaches a number with a negative sign and an exponent. This means to the left, or a little bit less. This, a number to the plus, means like to the right, or a little bit more. Think of it as an infinitesimal more or an infinitesimal less. Right. I am using that. Like, sure. When I can use it, I'll use it. Now, ready? If your left hand limit, if your limit as x approaches this number from the left of whatever function, gives you a number. And that number is equal to the limit as x approaches the number from the right. Then we say we have a limit as x approaches the number in general. This says if your left hand limit to the left hand limit equals your right hand limit, this is your right hand limit, then you have your limit in general. In general has no notation. We don't care about the function value at that location. This is very important. we don't care about the function value. We care about what's going on a little bit to the left and a little bit to the right.
So does that mean like where the limits meet, you don't care about that value?
If we are approaching the same location to the left and to the right,
Mhm.
but I have a point somewhere else, I don't care about that point. I just care about what's going on just to the left,
Oh, I'm
just
okay, I
to the
see
right.
what you mean.
Like that?
So, what if, like, let's say, like, when you have something, like, X, and the number's like 2 or negative 1, or 2 with negative 2, right? So it's always approaching that, or it's always approaching that, like a positive thing, so it's negative, or 2 to 1.
Plus just means a little bit.
Yeah, no, I got that. But if something's coming from the left, and you change like a fraction of exponent and something. No.
Like, well, when we do an example, say this, hey, Mr. Professor, change this to this. And then we'll. All right. If the left-hand limit doesn't equal the right-hand limit, the limit doesn't exist. But again, for limits, I don't care about what's actually going on at our x locations. I don't care about the actual y value. There may be situations where our limits, actually most of our situations, our limits and our function values will agree. But for the ones that are going to try to trip you up, we got to make sure we understand that they don't have to. All right, we're going back to our first example, okay? I'm giving you the graph, and I'm giving you the expressions for the piecewise functions. But now the questions are, what are these limits? And what is this function value? Cool? It's just like what we did, it just looks different. What is the limit as x approaches 2 from the left of f of x? I think about 1.999, which is just a little bit less than 2. I have this from x is less than 2. I plug in this, it's essentially going to give me the same thing as if I plugged in 2 into this, and you're right. Fine. Got that? If I plug in something a little bit bigger than 2, like 2.001, I'm plugging it into this piece for values that are bigger. I plug in 2.001. It's essentially like plugging in 2, I get negative 4 plus 5, I get 1. Because this number and this number are not the same. They don't agree with each other. This limit does not exist. Because this number and that number are not the same. Oh, sure. At 2, I'm plugging in 2 into this. I do get 1. I don't care. This makes no difference. I could have just like left this question off. Okay? I don't care about this and answer this. Okay? Now let's look at another situation. Let's look at 0. Okay. Well, 0 to the left. 0 to the left is like negative 0.00001. Oh, well, that's less than 2, right? All right, I'm going to use this piece. I can essentially plug in 0. I get 3. Oh, 0 from the right, 0.00001. Okay, well, that's still less than 2. Okay, it's still less than 2. I'm still plugging it into here. You're going to get 3. This one and this one are the same. I get this. I don't even care. Okay, it is 3.
If they're the same, will the general
Yes.
and general one always equal?
If this one and this one are the same,
Right.
That's your answer. Always. You will never have a different number than these two numbers. Ever, ever, ever. Got it? Right. Now, we could have gotten that just by looking at the graph counts. If I asked you to go to the left of 2, and this is important because we're about to just do an example that's just a graph. If you're to the left of 2, here's to the left of 2. Here are my y values, approaching 5. I'm up here. Here's to the right of 2. If I'm to the right of 2, where are my y values? Down here. Got that? If I ask you, what is F2? It's that point. Okay, like I am plugging in 2 into this blue piece. Okay? You need to be ready to do it just by looking at the graph. All right, next one. You know, even skip the 2s. Let's just do the 1s. You know, I'll do the 2s really quick. If I plugged in 2 to the left, 2 to the right, 2 in general, all of these values are bigger than 1. Since they're bigger than 1, I like this. I mean, I get 6 across the board. Done. That's the easy one. Six across the board. Easy. This is a point where we will say our function is continuous. And when functions are continuous, limits of function values equal each other. You guys fix and do the other one. One to the left, one to the right. One in general. What's G? Yes. Perfect. You got it. Nice. You go rapid, you go quick. Cool.
He's come back with
If we get things wrong, it's okay, guys. But what you guys gotta do is try. Okay? And again, like lessons are not for being masters. Okay? It's about for understanding. If you're getting examples wrong, try to fix like, why did I get this wrong? It's not about the answers, it's about how you get the answers. You understand how you get the answers. To the left of 1. A little bit less than 1. 0.9999. I'm up here. It's essentially like plugging in 1 into that. I get 2. To the right of 1. Ooh, 1.0001. Ooh, that's bigger than 1. I'm down here, I'm using that piece. Plugging in 1 into that. I get 5. I don't care that at 1, I get 6. I do not care about this number at all. This number and this number are not the same. This does not exist. Okay? Cool? Cool. I'll do the 3s for you. 3 isn't equal to -2. I can plug it in and I'll get 9 across the board. This is like a nice spot where the function value and the limit are the same. Easily you see we're continuous there. There's no crazy holes or circles or anything. But at -2, let's see if you guys can do it. Yeah, that's exactly.
Well, the other point is here.
At one. But I don't care about that. Yeah, guys, if you don't have this, you can still do this. You can still answer this question. It's still the same. It's the same question. We need to be ready for this. A lot of students mess up on this part. So, ready? Negative 2 to the left. It's not negative 2. It's not negative 2. It's a little bit less than 2. It's not negative 2. It's really, really close to it. Since it's not negative 2, I can plug it in here. I will plug it in there. And I'll get 4. This is not negative 2. Very close to it though. But since it's not, I can plug it in here. And I also get 4. Since this number and this number are the same, that's what the limit is. If I ask you what h of negative 2 is, oh, that is at negative 2. That is 1. But that makes no difference. Like, if this wasn't even here, it's wrong. That would still be 4. If I didn't have a point here, that's still 4. Okay? If I don't have the equation for the stuff, all the answers are still the same. Okay? One more where, remember this guy? This guy had a hole, but it didn't have a point elsewhere. Remember this guy? Sometimes people think sleep because, oh, this is so easy. Sometimes it's because of I talk about it. I know. Sometimes it's all over. And I didn't teach you this stuff much. Sometimes not. That's it. Now, here's the problem. I don't have all the extra questions. If I give you this out of the blue, you need to assume that the extra questions are there. You need to think about this and this before we comfortably answer that. Now, we'll find that it doesn't matter, right? I can't plug in 2. If I plug in 2, I get 0 over 0. That's undefined. You might want to factor. Okay, that's fine. However, you still can't plug in 2 into this factored form and get 0 over 0. You're not allowed to divide by 0. But if there was any other number besides exactly at 2, it's 2.001, it's 1.999, you can plug it in here. And if you plug in 1.99999 in here, you can cancel that. If you plug in 2.00001, you can cancel that. And you end up with 4, 4, 4. You will be asked, hey, if this is what our graph looks like, what's our limit and what's our function value? You should be able to figure out, oh, we are approaching 4 from the left and from the right, but I do not have a function value at x equals 2. F of 2 is undefined. You should be able to get that without the equation. You also need to be able to get it with the equation. All right, last one. Left, right, in general, function value. Now we like to say, this is always important, limits exist or do not exist. Function values are defined or undefined. Defined means it's a number. Undefined means put UND. This exists, it's a number, does not exist. So you shouldn't have undefined both places, still fine. But like this is DNE, this is UND. Okay? What do you use? If you plug in 0, you can't do that. Can't plug in 0, you get 0, 0, 0, 0 is bad. But if you plug in negative 0.0001, you'll get something. It's not divided by 0. It's divided by something close to 0. Positive divided by its same self. That's negative. Negative 1. Oh, I can see it on the graph. Same deal here. You get 1. This does not exist. This is undefined. Alright. What if I just gave you a graph? Go. You can do it just. Oh, you know what? That's like the test. Alright, do this while I put the test. If you put the test away, sorry. How do everybody
Right? Because it's not actually a point, it's just a
One.
Right here, negative 2.
everybody over here? Test
Yeah, it's very same, but it just doesn't exist. From the world. Yeah.
I can use this.
They approach each other.
No, what did you say was the first?
Negative 2. 4, negative 2. I'm sure they're both negative 4. I'm gonna hold as a.
Yeah, no,
Yeah,
it's
yeah, because the effort. No, it's 1 and left.
Oh, one? Oh, I was confused, I was like, how are you getting?
So we're thinking about 1, right?
Oh, yeah,
Yeah.
Plus
Well, I'm
4.
at the other class.
Something divided is
Take all the
negative
tests.
2. I'm pretty sure. 6.
All right, everybody over here, put your answer document inside your test. I'll come around and collect your test. Answer document inside the test. I'll put the test.
So far. And then
There's a hole of 2. Or whatever. This one's 2.
there's a hole.
Yeah,
Yeah.
there's 1 is 2.
Divided to
So wait, so
F
yeah,
of
that's
6 to C, because at 6 there's a 4.
Sorry. I haven't had a chance last year, so that's why I'm thinking. Says less. So, do I automatic test? Test. Okay. So can I pick it up what's about to take? And then test, yes. Can I get your test? Yes. Steve, did I get your test?
It's 5 overall. 1 second.
Yeah, did we all get it right?
I'm not even, I'm getting my head.
You see point. Right at -4. I see an open circle. That is just like this example, where we have a hole and not a point. This is 0 to 0, but that that's just like that. All right, so if I continue the graph, ready? You just look a little bit to the left and a little bit to the right. -4 from the left, -4 from the right. Just a little bit to the left, a little bit to the right. I don't care that there is no value at -4. There is none. That's important. There's no point. If there was, it wouldn't even have the closed circle there. It would just be like a smooth graph like that. But this is just like x squared minus 4 situation. X squared minus 4 over x minus 2. It's just like that. We are approaching a y coordinate. But you can't plug in -4 and get a y coordinate. You get 0 over 0 if you plug in -4. But you can plug in -4.001 and -3.999. So far so good? At 1. If I go to the left of 1, oh, okay. To the left of 1, that's using this piece. Actually, this piece is being used for all x's less than or equal to 1 because it ends with a closed dot. So actually, if I'm looking at this red piece, I'm going to go ahead and answer that. That's 4. It's not that there's 2 y values. It's like I have a closed dot at 1. Okay, that's the whole being less than or equal to, greater than or equal to. And I approach that value 4 by pointing 0.999 equals to inch. If I'm to the right of 1, though, I'm at this piece. And this piece is being used for x's that are greater than 1. Not greater than or equal to, just greater than 1. So this piece is just x is greater than 1. But this piece is not used at 6. At 6, we're using the point 2. Okay? So, using the blue piece for 1.001, approaching -2. This and this do not agree with each other. So it does not exist. I don't care that there is a point 1, 4. If I go and look at this last guy. Six to the left, 6 to the right, and 6 in general. This is using the blue piece for all of the x's that don't equal 6. At 6, I'm using that green point, 6, 2. Use that green point at x equals 6, I get 2. But all of the other values around 6, we use this curve. And this curve approaches 5 from the left, 5 from the right, which means the limit is 5. You got that? All right, good. You got that? You guys are close. All right, here's a AP question. Let's give them AP test. What's the answer, A, B, C, or D? D. D? D?
It's like what you plug it in for is when it's
How do you know it's B? Exactly. Does everybody know that it's B? Some people said B. All right, good. It's B. It's B. It's B. B.
The other ones are 10, 100, 4.5, 9, the Y value G is 95. It's when 9 equals 5. 9 equals 5.
Yeah, let's go.
It's B. As our x's get close to 9, as our x's get close to 9, our y's are getting close to 5. All right, what's A? Write it down. Write it down. Write it down. What does A show you? What does A show you? Yep. Yep. As our x's get close to 5, our y's are getting close to 9. What about C? What does C show you? What's C show you? Shows you that to the left of 9, it goes to 5. It shows you that to the right of 9, I'm getting close to 10. That means, if I wanted just one statement, it does not exist. A graph has like a jump, it's going to jump down. Cool. You're going to replace these. You have some questions on your homework that says do this with a calculator, add on to it. We kind of understand.
Street cost as well.
I don't care. We do them, don't do them. I do them in the homework video. Do them or don't do them, okay? But you're not using a calculator on your quiz. I say that again. This one, don't worry about. We'll talk more about how this is the location of an asymptote, and an asymptote's limits going to C. Okay? Like, if you have an asymptote, you don't have a limit. You're approaching infinity. We'll talk more about that in a couple classes across that form. Okay? Now, all of the previous questions was like limit x approaches number f of x. Limit x approaches number g of x. This is limit x approaches number, and then they give you the expression. Tell your neighbors, what are you going to do? Don't let it suck you out. I mean, would it help if I said f of x equals x cubed plus 2x? And I'd say, what's the limit as x approaches 2 of f of x? Does that help? No, right? It's the same thing. It's like, okay, well, you're probably thinking if you are doing things correctly. And then you'll get to like, oh, I don't know, you know. If you were Polish, you're probably thinking, oh, I got to plug in 1.999. Well, I got to plug in 2.00001. But then you're like, okay, well, that's like plugging in 2. And then you're like, oh, you just plug in 2. You get 8 plus 4, it's 12. Yeah, most functions, limits are easy. Limits are easy to find for functions that don't have any weird things going on. You don't have like a jump or a hole. There's no divided by 0 anywhere. If it's not a piecewise function, it's a piece of cake. Just plug in x. Okay? Because if you plug in x and you get a y, if you plug in something a little bit less and a little bit more than that x, you're going to get that same y. So, what's the sign of 2 pi over 3? The answer. What's the sign of 2 pi over 3? Who's doing it in their heads now? Anybody? Anybody doing it in their heads now because you're like, we've leveled up?
Yeah.
Yes. I love it. All right, wait. So this is easy. I just plug in 2. All right. This one. What's the limit of x? Limit as x approaches 3 or 4. Talk to your neighbors. Don't shout it out so everybody hears you. Talk to your neighbors. What's the limit as x approaches 3 or 4? It's a funny one, isn't it? You guys are shaking your heads, you're like, Professor, it doesn't help. Are you writing like this? Maybe this one does. Oh, maybe that doesn't help you. Maybe understanding f of x gives you y. Maybe that helps. Y equals 4.
Yeah, because this is
For any x value, I don't care. It's 4. For 3, it's 4. For 2.999, it's 4. For 3.00, it's 4. That funny? That's a good one. Alright, we'll do plenty of practice. But let's go to these bottom ones. This is what's not in your notes that you're going to replace what was crossed off. So, remember you crossed off the calculator ones? Replace them with these. These are not in your notes, you're replacing the ones you crossed off with the calculator. They're not just in the calculator. Replace them with you can cross off the calculator section in your homework. It's very short anyways, no big deal, but you don't have to worry about figuring it out. Yoga. Oh, using it. Okay, so we're replacing the with a calculator section with this. Wanting to change this. Okay. Okay. All right. Guys, we did this one. We did this one. We literally did this one earlier. Practically, this was flipped. Okay? Guys, literally x approaches 4. Well, in all the previous ones, we were like, hey, if it's nice and easy, you just plug in 4. You plug in 4, you get 0 over 0. Most of you, and so many students on tests, were like, okay, does not exist. 0 over 0, I can't do it. But that's when you plug in 4. Right? 4, you get 0 over 0. But what do we talk about? You're not plugging in 4. You're plugging in 3.99999, which means you're not dividing by 0. Which means you're going to get something if you plug in 3.9999. It's not 0. So since it's not 0, it's not undefined. This does not exist. This is when we factor. This is when we think about x minus 4 over x plus 4, x minus 4. This is when we realize, oh, 0 over 0 is actually a location of a whole. If we factor, we realize that, hey, I can cancel out those. I can plug in 3.9999 because this is going to be a number, and this is going to be the same number. It won't be 0. It'll be something close to 0. there won't be 0. And if I do that, we'll get 3.9999. And these two numbers that are very close to 0 cancel. I get an 8 on the bottom, right? 1. Because we cancel, not 8. 8's on the bottom. Hold on. Yes, there.
It's on the bottom. That's
So-
still 1.
Question was, should we always factor first?
Yeah.
The answer is yes, but don't cancel. Don't cancel, okay? I mean, you can, but I might ask you for this question, hey, guys, what's f of 0? And then I might ask you, hey, what's the limit of this? When I ask you what's f of 0, and this is already factored and canceled, you're going to give me an answer for that. But f of 0 is undefined. You are not allowed to plug in 0 into this. But you can plug in something close to 0 because you are going to get something in the denominator. How do we factor this guy? Tell your neighbors, how do you factor that guy? This is a common one that shows up. Something just like this. Yeah. You'll see it on your homework. Wait. No.
That's 1.
Oh, nice.
We multiply by 0, 0. So you square multiply by 0, 0, x squared, x squared.
Oh, wait, but if you multiply 0.
Where you multiply by 0, 0.
So you're not even
All of, look, all of these are 0. All of the exponents that we multiply by 0 are 0.
Yeah, but
So the base is like that.
look, here's 0 right here.
Well, it doesn't matter because the exponents
So,
are
ready?
the
I like this.
greatest power is the
Greatest common factor can be factored out. On the top, an x squared can be factored out. You got 2 plus x cubed. The bottom of 3x squared can be factored out. You have 2x cubed minus 1. Now, this helps you see the values that you are getting when you plug in something close to 0. Because this number divided by this number, very small close to 0 numbers, but they will cancel each other. Again, they're not 0, they're close to 0. Leaves us with these. Okay, but now we still have to plug in something close to 0 into this and into this. And when I plug in 0 into those, I have a 1 times 2 plus 0 over a 3 times 0 minus 1. So my answer is actually negative 2/3. Sorry.
I really haven't read I have the 2.
Why is it negative? Because it's 3 times 0.
I didn't hear you say that.
Okay? Yo. Great lesson, hope you understand. If you do understand, do the homework. And oh, hey, don't rely on video, right? You understand? Try the homework. Try the homework. Do the whole homework. I need everybody's test. Not giving your test. It's